Right. Okay, got it. So maybe I have to share the screen share. So can you see?
Yes, I can see.
Okay, Rahul bhai.
The screen is visible.
Okay. So can I start?
Yes, please.
Okay. Good morning, all. So today we will be discussing something a little bit philosophical and Newtonian gravity and the present status, so to say, the fine tuning aspect. So the title of the talk will be the Mach principle and fine tuning of the universe. So we are very familiar. We are very familiar to these two equations since intermediate days, so to say. Let's suppose F equal to ma. It is the Newton's law of motion. We usually get to know it in terms of the second law of the Newton. Force equal to mass time acceleration. And another very familiar equation is F equal to g mm over r square, which is nothing but the universal law of gravitation. So at the far side, it doesn't actually initially when these two equations were written down by Newton around 1680 each, these two masses were not looking equivalent. But the assumption behind this equation, force equal to ma or force equal to g mm over r square, this m stands for inertial mass and this m stands for a gravitational mass. But the basic and common assumption what Newton had taken into account was the concept of absolute space and absolute time. So actually this equation did work exceptionally well for 250 years nearly. And of course, the Einstein general theory of relativity is actually doesn't violate it or doesn't prove it to be wrong, but it is a limited version of the Newton's theory. I mean Einstein theory. So first one is, what is the absolute space? So coming back to the very famous Newton bucket experiment, what Newton did in the early days in order to prove that actually this is with regard to the absolute space, what he did, he took half fill bucket of water and then he started rotating. So we also have experienced it some or other, that if you rotate the bucket, you can see the concave space, concave nature of the water surface. So the water actually, a water surface in close proximity to the wall of the container actually rises up. And what Newton actually claimed this, as this nature of the water surface arises due to the absolute space, due to the existence of absolute space. And similarly, absolute time, which we will not discuss in the present context. So this thing was very sarcastically and vocally attacked by the Viennese philosopher and physicist, of course, Ernst Mach, which we know him as a Mach number in sound wave study, supersonic, ultrasonic, and all that. This Mach said, no, it cannot be. So he was like, so instead of a finite sheet of a bucket wall, if you would extend it to the kilometers or miles away, how it would have actually happened to the water surface. So he actually was not convinced with the Newton concept of absolute space and time. Although Newton was aware of the fact that both elephant as well as ant, they both will fall under the action of gravity in equal interval of time That means we call it in a technical jargon acceleration. That's why we often used to eliminate the mass term and express it in terms of gravitational mass of Earth and the gravitating body. That G equal to Gm over R square. Usually, the acceleration due to gravity. So Mach actually not only he stopped here, he further extended the idea, saying that instead of absolute space, actually where the this inertial mass or a gravitational mass is responsible, inertial mass is responsible for the acceleration of the body. Or what is the inertia? Inertia is the resistance of a body to accelerations. Okay. And the second thing is the force equal to gmm over r square, that gravitational mass. It is nothing but this is the source of the gravitational attraction, whatever we see around the around us in earthly bodies or in universe. So what is said, there is no concept of absolute space. First of all, Newton did not two things I just want to underline. Newton did not explain the propagation of the gravitational attraction, that he left to the reader. Second thing, he did not actually explain what is the origin of inertia. He simply said, under the compulsion, the body can actually change its state of rest and state of motion, which we know as inertia. But he did not discuss anything about the origin of that inertia. Likewise, he did not also discuss about the concept of absolute space. I mean, why they both have to be equivalent, means inertia and gravitational mass. Though he was aware of the fact, but he never discussed it. The instantaneous action at a distance and the origin of inertia. These are two very deep philosophical or physics questions that remain unsolved till the date of Albert Einstein, who actually explained the action at a distance, what should be the optimum speed that we know today, which is nothing but the speed of light. And second thing is the origin of inertia is still a question. It is an unsolved question even today. But that is the question was attacked by Ernst Mach, and the resolution he came up with is this: both inertia as well as gravity of a mass are actually due to the distribution of the other distance matter in the universe. It has nothing to do with absolute space. And what is said, the distance between two objects, actually what Newton was referring to, but he said without the distribution of other matters, what is the concept of space? It doesn't make any sense to discuss in the language of physics. So that was his resolution. So this is still an unsolved problem and a unfinished revolution, one can say, because that experiment even cannot be performed. If one want to actually know whether the inertia existed by any body is due to the distribution of the rest of the body in the universe, one has to actually throw out every matter, every energy, everything, literally to say to everything outside the universe, and we do not know how to do that. That's why the experiment remain unfinished, and so is the resolutions. Then not only Ernst Mach invented the concept and attacked the absolute concept of absolute space. Immediate after Ernst Mach, so Erwin Schrödinger also investigated along the same line, and what he found, the unit of gm over r, gravitational potential, is nothing but proportional to the square of the speed of light. And when did Schrödinger investigated it? It just before the cosmology began. Cosmology began, I mean to say, in 1929, Hubble actually experimentally shown us that universe is expanding. Even Einstein also did not know that the universe is actually dynamic. He was believing in the static eternal universe. So this investigation happened in 1911. So, and he remained silent thereafter. This is the very famous formula and paper produced by Albert Einstein in 1911 when he was a professor of physics in Prague University, Czech Republic. And this is nothing but the formula associated with the variable speed of light, they call it. And he also found this phi is nothing but a gm over r. Likewise, sorry. Then came the PhD thesis advisor of the Roger Penrose, the Dennis Skyma, and they also investigated, and what they have found, oh sorry, that is nothing but the distribution of the mass, and this Ri, the distance, is nothing but c square, and this is Robert decay. These two, 1957, and this he probably 1953. Dennis, I don't remember it. So again, this is proportional to the speed of light. So what essentially I mean to say from here?
Yeah.
Hello?
Yeah. So my question is, what are Mi and Ri in the last equation?
Yeah, that AMI stands for the distribution of the mass in the universe, and Ri the corresponding distances.
Assuming some origin.
Assuming some origin means if we are actually trying to explain the inertia of one body which is resting on your table right now with respect to that mass.
Okay. So that body is not taken to be the origin.
Yes.
Okay.
So if at all it is actually exhibiting some inertia, what is the origin of that? Origin of that is nothing but the distribution of the rest of the matter distributed in the universe.
But then but then the mass of the body does not itself come in this equation. So what do you relate with the inertia?
Sorry?
No, so my question is,
Yeah.
here MIs are the masses of every other object in the universe. But
Yes.
what's the mass of the object itself?
No, mass of the object is not taken under consideration, because you imagine I am telling the mass is nothing but the resistance to acceleration, or which is otherwise known as inertia. You can actually put the logic otherwise. If imagine there is no matter except the matter under consideration, in principle it should not have any inertia, and hence the mass.
Okay.
If it does, there is no way to measure it. I understood in this way. I have understood in this way. What is saying, if the body is showing some resistance to the outside agent, which we call force as per the Newton, but that resistance or inertia is nothing but the byproduct of distribution of other matters. So if we ask the question, how about if other matter doesn't exist? Then you imagine a single piece of matter evolving or floating in the entire universe without anything referred to. Then probably it will not resist to anything. That's what the Mach principle says.
No, so my question is, because now right now we are trying to understand what inertia is.
Okay.
So an inertia, perhaps whatever that inertia is, it's somehow related to the mass of the object, the inertial mass, let's say.
Yes.
Okay. So
Yes.
and in this equation, in the last equation you have written here, MIs are the mass of the objects other than the body which is under investigation.
Yes.
So I mean, if I were to relate the inertia and hence the mass of the object under investigation, where is
Okay.
that mass coming? So, I mean, how will I relate that inertial mass to? I'm not able to ask my question properly. So, my question is, okay, because we want to investigate that body. So,
Okay.
and where is that information in this equation? Because we have to eventually relate it to something else. So, we are
Yeah.
saying,
We are actually indirectly saying that this is exactly in some way it is equivalent to the mass under investigation also. But the message is that mass is, or that resistance to acceleration is nothing but the consequence of a distribution of other matter in the universe. Now, do I make any sense?
so would it be true then that if you multiply both sides by the inertial mass? No,
Yeah.
it won't work. No.
No. You see the first equation I have written down here by Ernst Mach, the first image. G equivalent to C square R over RU subscript divided by MU. Okay. This mu is the universe mass.
Okay.
That means matter of the mass of the universe. That means mass of the matter in the universe. So that means the mass what we are actually measuring of matter or under investigation is nothing but equivalent to the mass of the other matters or a distribution of other matter in the universe.
So in this equation, when you take mass of the universe, you don't include the mass of the object and the
No,
of course that will be very small. I agree. That will be very small as compared to the mass of the whole universe.
no,
But still,
that is one point. The more important logical point I believe is that if you do not isolate the effect of other matter on the matter under investigation, then how can I say that what is their effect? I need to isolate that.
okay. So first you isolate and then see how the object under investigation behaves, and then you include the effect and then you see how does it behave.
Yes, yes.
Okay. Okay.
This is how it is, I believe. Because if you imagine right now the concept of the Newtonian mechanics, if there is anything happening in the background of the absolute space, we don't include a contribution of the absolute space, do we? We don't.
Okay.
Likewise, we're actually investigating the absolute space in terms of distribution of other matters. What role those distribution of matter could probably play in the subject under investigation.
Okay. So one more question is then, so by using, let's say, the fourth equation, are we trying to somehow get to the notion of space? Is this
Yes,
correct?
exactly. There is, according to Mach, absolutely there is no concept of space, because you are very familiar with another revolutionary British physicist, Julian Barber. He has written there is the end of the time, a very famous text you would have seen. He says there is nothing called time. Of course, as followed from Einstein, but that another lecture we'll see sometime if we can discuss. But here, what I mean to say, as per the Ernst Mach, there is no concept of absolute space on which every event is happening. No, if you are seeing any physical effect, it is just because of presence of other matter. If you then one can ask. Now imagine if one object is there and there is absolutely literally no matter in the entire universe, will it possess inertia? Will it still follow the Newton's law? That's the question. That's the question. As per the Mach, in principle, that object should not resist to anything, because there is nothing to refer to, or there is nothing to attract, nothing to repel. There is no physical effect in principle you may have end up with probably.
So if I've understood it correctly, will it be right to say that if no matter, no object, let's say I remove even the gas molecule, I take only the object that I want
Yeah,
to study, and I
yeah.
remove everything from the universe, assuming I've removed gas molecules, everything, every
Yes,
possible
yes.
thing, then there
Mathematical,
would be any
literally.
inertia.
As per Ernst Mach, it should not
Okay,
exhibit any inertia.
okay, okay,
But if you do ask me another tougher question, if there is no inertia, then can it move with the speed of light? That I do not know about.
okay, okay. Yeah, please continue.
Yeah, this is how the thing has started.
Okay.
But here, if you see, there is a very non-trivial relation they all have tried to introduce. What is the intricate relationship between the gravitational constant and the speed of light? In all those relations, if you see, they all have somehow or other tried to relate two very fundamental constants. One is gravitational constant, and another is the speed of light.
Okay.
Yeah. But till today, we probably do not have that concrete evidence and strict relation how they actually interrelated.
Okay. Okay. Please continue.
Okay. So Ernst Mach actually did not live that long to see the evolution of the universe or all these cosmological revolution as introduced by general theory of relativity, because he died in 1916, just 1 year after publication of GTR. But after 25 years, 1893 probably he has introduced this concept. Then Albert Einstein came up with this brilliant idea, for which this has acted as a seed of a general theory of relativity, which he himself has admitted. So inertial and gravitational forces are similar in nature and usually indistinguishable. This is very uh, I would say Ernst Mach and Isaac Newton have made the Albert Einstein life little easy in that sense. Then up to this I'll register myself. So other thing maybe I'll make another talk. So we'll discuss more on that. How does equivalence principle have lead to all that? So, but one thing I want to tell here, the point I wanted to make. This is known as variable speed of light concept. When Albert Einstein and the happiest thought of his life, what he called the principle of equivalence or equivalence principle, he conceived in the year 1907 in the patent office. Then he was investigating how to introduce gravity in the relativity. And in the process, actually, he came up with this formula, which he published around 1911. But again, this thing totally gone unnoticed, and he himself also did not concentrate on it. But I have enough evidence that he was actually very consistently indicating that one should actually pursue along the variable speed of light. Even after a long year of publication of general theory of relativity, which he himself has come up with by geometrization of the gravity. The people call the geometry dynamics. He was believing there is something, but here one can actually prove every prediction of general theory of relativity by considering the byproduct of curvature of space-time, except perihelion anomaly. That thing has not yet been solved by considering the variable speed of light. Otherwise, bending of light, bending of space, or gravitational redshift, everything one can actually predict and very precisely, which will tally with the experimental finding. Anyway.
Gandhi, can you please go back to the previous slide? Yeah.
Yes.
So in this equation, in the third equation, C equals
Okay.
C naught times 1 plus
Yeah.
5 over C square.
Okay.
The C square in the denominator is not C naught square, it's just C square.
Yeah, that is the speed of the matter body, object. C0 is referring to the normal speed of light in vacuum.
And C is the speed of the object.
Yes, yes.
So because you're also saying variable speed of light, so is this why you have removed 0? So C0 is the speed of light in
Normal.
vacuum.
Yes,
That
yes. It is
Sorry,
the
meters
very
per
much.
second.
Sorry.
That is 3 into 10 power 8 meters per second.
Yes, 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 yes.
But then as you said that C is the variable. So here C is a variable. So then if I were to, so let's say you give me some phi, which I suppose is the gravitational potential,
Okay.
or related to that. Is it correct?
Okay. Yes, yes, yes.
Okay.
Yeah.
So then given gravitational potential, this will be a cubic equation in C. So so you have to solve that cubic equation for C. You will get some values for C. Is this correct?
Yes.
Okay. Okay. Continue.
So literally you may consider it is the second part, but I find it fancy and worth knowing and discussing. So that's why I have put it into the systematic way. So what would have been our actually there had been a recent debate whether our inverse is fine tuned or not, but many science popular text or textbook or the PhD or MSc students, those are also referring to the fine tuned inverse, which you all are very familiar with. So here actually we'll deep little deeper and see actually is it really fine tuned, and if it is, then how. So the first is the ratio of the mass of the electron to that of the proton. So we know from the very high school physics, this is the mass of the electron and this is the mass of the proton. Okay. So, but here you may find it surprising. How come it is order of magnitude smaller? But it is a condition applied. What if the mass of the electron would have been much larger than the mass of the proton? So if you actually study the atomic physics, then it would have actually made the orbit of the electron quite smaller because it has to move faster. Okay. Then one would have required higher ionization energy to eject an electron from the orbit or remove an electron from the orbit. Then what is the net consequence? Then it is the business in the atomic domain. Now, if you get to the cosmological domain or domain in astronomical scale, we know that very famous Chandrasekhar mass limit for a white dwarf, and this is the expression of their mass. So if you see the mass of the electron would have been smaller, then the Chandrasekhar mass limit would have been higher. And if the Chandrasekhar mass limit will be higher, then the degeneracy pressure may not actually sustain the gravitational collapse. And if the gravitational collapse will not be counterbalanced by the radiation pressure, then obviously the thing will be a lighter neutron star, because in white dwarf we know there isn't much mass to produce the supernova or big explosion where the outer portion of the star would go into the space. And why I am telling this very known fact, during the explosion, the outer portion of the star will explode and envelope will go very deep into the space, because that is the process. That is probably the process where all the heavy element have been formed in our periodic table, and without heavy element, we know we cannot survive. So that is why the reduction of the heavy element needed for the light will not be there if the mass of the electron would be much higher than the mass of the proton. Because this is
Yanti,
yes.
I mean, it's very difficult to believe this because of the reason that let's say I assume that the mass of the electron is very large as compared to the mass of the proton. Okay.
Okay.
So
Okay.
in that case, to me it seems that
Hmm.
the position of the electron and the proton will be swapped. So instead of electron moving around the proton, because
Hmm.
usually this is what our understanding is, that the proton mass is about 1000 times as compared to the mass of the electron.
2000 times.
Okay. Yeah, about that order. So
Yeah.
so now if I say that the mass of the electron is greater than the mass of the proton or very much large as compared to the mass of the proton, then their roles will be swapped. So then proton will move around the electron, and whenever there is some sort of ionization or whatever, then the proton will be knocked out. So to me it seems it's a convention. So we are saying that the electron charge is negative and proton charge is positive. So if I were to just rename them, that the
Okay.
proton charge is negative and electron charge is positive, will it not be the same? So why would there be any change?
It's a very good question. It's really a good question. So, as far as the charge is concerned, I am very much agree with your logic and argument. Very correct, because that is nothing but the convention. But when it comes to mass, now imagine if electron is actually, instead of electron revolving about the proton, but the proton internal structure will not change. Will it change?
Oh yeah, because proton is
UUD.
hydron and electron is a lepton.
Yes.
Okay, in that way.
Yes.
But then if the mass, no, see, my question might sound a bit stupid, but then so what I'm saying is
Ah,
replace all electron mass with the proton mass and
okay.
replace all electron charge with the proton charge. So
No,
will there be any effect?
you are correct. You are correct. There is some limit or range. If you actually change the electron mass as compared to the proton mass, your thing might be correct. might be correct, though not exactly correct, because as we have discussed, the internal structure and their making is different. But I'm telling it is way bigger mass.
Okay, so my understanding is, so when you say that the mass of the proton is very small as compared to the mass of the electron, and assuming that there is still, so let's say the proton is still a hadron and electron is still a lepton. So
Yes,
then it means that the mass of the quarks has also reduced.
yes, 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 yes.
Oh yeah, then it may have some, yeah. Then in that case it might be possible. Okay, yeah,
Yes, yes.
that
That's
is
why
fine.
I told your question is very tricky and it's a good question to have raised. But without changing our internal structure, so to say, let's say up to our limit, up to quark, internal mass has to change, na? Otherwise,
Yeah, quark's mass will change. So and then it will have very radical effects. Yeah, that is true.
yes,
Now,
yes. So the whole point is that if the atom, the beauty of studying the astrophysics is that there is no branch you can actually get rid of. You have to touch upon every branch,
mhm,
starting all the way from mathematics to the engineering, everything,
mhm,
chemistry,
mhm.
biology, everything. So we have actually discussed the bit of atomic physics where we have seen if you actually change the atomic mass of an electron or little higher, then you will end up with the reduction of the heavy element which is needed for the life.
Okay.
Okay, so this is the one point. Second one, ratio of the mass of the proton to the Planck mass, and this is the Planck mass definition. I have put it here. This is what the Planck mass, and mass of the proton, of course, I have mentioned in the previous slides. So what happens if Planck mass would be larger than this? Very similar to this. If Planck mass will be higher, then obviously this white dwarf will no more be very effective. Again, it will not survive the gravitational collapse.
Kyanti,
Again,
if I may interrupt.
please.
So Planck mass is anyway larger than the proton mass because Planck mass, if I remember it correctly, is of the order of 10 power minus 5 grams or of that order. But or as you have written, the Planck mass is 10 to the minus 8 kilogram, but the proton mass is 10 to the minus 27 kilograms. So it's anyway larger than the mass of the proton.
Yes, but I'm considering even further. Even
Uh,
further.
that the mass Planck mass is even larger, or the proton
Fast
mass is
case.
even smaller.
No, fast case. What you said that is correct. Okay.
Okay.
Fast case is as it is represented here. Planck mass is as usually is larger than the proton mass.
Yeah. Okay.
But second case, I'm what if?
Okay. What if the mass of the proton is very much large as compared to the Planck mass?
Yes.
Okay, fine. Thank you.
Yeah, this is what it is. So if that is the case, again, gravitational collapse will not be counterbalanced exactly by the radiant pressure or thermonuclear reaction, and which actually further deprive the collapse event. And if by any means you are restricting the collapse to happen or supernova explosion to happen, then you will end up with the limited number of heavy element. I will discuss one very sensitive part of the formation of the element in the nuclear reactor inside the star core. The next. So the message is from these two, the evolution of life has been very sensitive to the ratio of the proton mass to Planck mass or electron mass to the proton mass. It seems like actually these two factors, the mass of the electron and the mass of the proton, are essentially playing very decisive role in the formation of the star and thereby the life on planet Earth as we know it. This is very trivial, this thing, proton mass and neutron mass. But here a bit of nuclear physics. The neutron mass we know that is larger than mass of the proton, and that is after the third decimal place. Okay. So the question is, this is very familiar equation. Everybody is quite familiar with this. Neutron converting to proton, electron, and antineutrino. We all know that free neutrino decay within 15 minutes. If outside, it is 15 minutes. But inside the nucleus, it doesn't happen so. And this extra mass actually play the decisive role. This much mass only, 49 minus 26, just a 23. This point 0023. This mass difference actually play exceptionally important role in order to stabilize the nucleus, because the nuclear force, the formation of proton inside the nucleus, it needs a little bit extra energy, because inside the nucleus with a definite boundary, if you put large number of proton, you have to encounter a large number of repulsion, huge amount of repulsion, which is of electrostatic origin. And in order to compensate that, you have to provide energy, and that energy actually is coming from this mass difference, binding energy. This excess energy. Had it been little different, then your nucleus will be way unstable, and rest is just a story. But if the neutron mass will be little smaller than the mass of proton, then obviously all the proton and electron will immediately combine and form the neutron, and the neutron will be only neutron. It will be a neutron star, and a neutron star, you know, the excess energy will be released as a neutron, and there will be no chance of formation of the heavy element. So you can easily imagine, I was really got shocked what sort of role this minute mass difference actually essentially play in the evolution of life. That is in the third order. Okay. Then
Gyanti, and one more thing, can you also suggest the reference? Where did you read this from? Because this seems very interesting. I also want to have a look at that.
I have given. I'll tell you precisely where did I get it from. So
Okay.
I'll tell you.
Okay.
So this is one thing, and this is another thing what really amazed me. This is related to one of our greats, Jonathan Narlikar sir, and Fred Hoyle, the sir Fred Hoyle. Narlikar Hoyle model, Rahul bhai, you might be familiar with, because they have given some models. So here we know we used to ask to the student, and we are being asked also same question. Tell us the procedure where the different ingredient of the life or element form in the core of the star. The most essential element is the carbon. But if you look at the constituent of star, it is nothing but a huge amount of hydrogen and a very few amount of helium and lithium. This is what actually Big Bang, from Big Bang, if Big Bang theory is correct at all, that's what it says. But a large amount of hydrogen cloud actually star starts forming, and detail will not go into. So if 4 hydrogen actually combine together, then we'll end up with one alpha particle or helium nucleus and some extra energy. Okay. But after helium, how did the next element started forming inside the core of the star? That was a big challenge, because actually if you look the formation of the carbon atom, if carbon atomic number is 6, so in principle you have to combine 3 alpha particles, 2He4, 2He4, 2He4. But that is quite unlikely inside the star, because they are a similar charge, and you need enormous amount of energy to bring them together simultaneously so that they can form a stable carbon nuclei, which is very unlikely. But what Fred Hoyle actually he gave a model that probably there is an extra bit of attraction among the alpha particle inside the star core, what one can expect they would have outside the star. I mean, in normal circumstances, the attraction between the 3 alpha particle is little smaller as compared to the attraction between them inside the star core, and that is exactly experimentally being verified. And they call it the excited state of the carbon atom inside the star core. If there will be a slight mismatch, the excess energy or lesser energy, this carbon nucleus would have been impossible to form inside the star, and the rest is simply unimaginable if carbon will not form. And then once you have carbon, Then you can add on further helium nuclei and keep on constituting the higher element, heavier element till iron. But after iron, you have to go through the different process altogether to get the heavier element. That's where we need supernova explosion. In an enormous amount of energy in a blink of an eye. Actually, the rest of the periodic table element does form. So the carbon actually, which is the basic building block of any organic life, what we have seen today on this planet, actually has a form very sensitively, very cleverly by Mother Nature inside the heart of the star. So they call it excited state of the carbon nuclei. So it is very, very interesting what actually Fredo has proposed. And obviously, this is another beautiful aspect, the strength of the hardcore nuclear repulsion. We have already discussed the ratio between the different masses, proton, neutron, proton, electron, and proton Planck mass. And here comes the formation of the carbon nuclei. And then comes the nuclear repulsion. Imagine if there would have a little higher or a lower nuclear repulsion, then obviously the nucleus would be quite unstable. But this is another beautiful relationship between the radius of the neutron star is approximately 3 times the square child radius. If the repulsion is really not strong enough, then the compression of the gravity or the self-gravity would be sufficient enough to actually compress the star into its black hole state. And if a black hole forms, then obviously no heavy element can form. So the message is the subtle balance between the radiation pressure and the gravity due to this fixed fixed number, what we call it constant, fundamental constant. Heavy elements somehow getting formed due to the evolution, due to the explosion of the supernova. That actually is the responsible for the evolution of life in this planet. Neutron star would have almost larger radii, but what if repulsion is strong enough? Then if the density will be lower upon neutron star, then explosion will not be that violent. And if explosion will not be that violent, energy required for the formation of a heavy element won't be available. Okay, so then life would be impossible to imagine as a consequence. And this is very familiar. What Rahul bhai you are very much familiar with. We know the galaxy formation is essential for the evolution of the life, but the galaxy formation happens due to the presence of dark matter. That we know, and this ring is nothing but the dark matter ring. Another important point I just want to aspect. Imagine if our star would not have burned inside the galaxy. Now imagine if a star would have formed in an isolated, dark, deep space. What would have happened? Okay, a new star has formed, supernova explosion has happened, a cinder remains, which will become subsequently as a neutron star or black hole, depending upon their residual mass left out. But what happened to that envelope? What happened to their explosion? The heavy element has formed. Now they have totally spread in the deep sea of the invisible space. But that will not further used effectively for the formation of the planet where the life could evolve. So that is why this third point is no second generation star would have ever possible without galaxy formation. So galaxy formation is that important. So not only star has to form so that we can burn, star has to form within the galaxy so that those first generation element or star byproduct could effectively be used by nature so that we can form. Okay. Then the last one, probably the balance between dark matter and dark energy. You know, the critical mass density of the universe is nearly, I think, one, gravitational potential energy and gravitational and the kinetic energy of the entire universe is really compensating each other, and that's why universe is look like that. Though this concept was effectively explained by the inflationary model of the universe, but it doesn't really say anything. Why does this ratio actually have come about? Why 68.3 and why 26.8? Had it not been in this ratio, obviously our life would be impossible, because without the presence of dark matter, there won't be any formation of galaxy, and subsequent thing will not follow thereafter. So it is as important. Not only the existence of dark matter and dark energy are important, they have to have in a proper ratio, so that our planet
Actually,
can tell.
the, the presence of dark matter is essential for the early formation of
Formation of
galaxies.
galaxy. Yes.
So it's not that if the dark matter was not there, galaxies would not form, but they will take much longer time to form.
No, no, that's what I'm telling. Galaxy will form, star will form, as we have discussed. Isolated star even today are forming. They have also have formed in the uh, long past. But the life what we are actually experiencing
Yeah,
will not
life
form.
would not. Yeah, yeah.
Yes.
It
The
it it, it
all
would take even larger, even longer time.
yeah, to put it in a in a rescale it, to rescale it, if you imagine the entire age of the universe, let's say 13.8 billion years, into one calendar year, the human history has just happened for last 10 seconds. This is how this much long past we have actually. In order to make a human life which can investigate about their own origin and the evolution of the cosmos, where we all have evolved. Oh, we have just existed for last 10 seconds only, if the universe has formed in last 1 year. So yeah, these are my references. Gravitation and Cosmology by Steven Weinberg. And this gravitation, of course, from Misner and Wheeler. Then Einstein gravity in a nutshell from AG. And space-time and geometry from Sean Carroll.
Okay.
Thank you.
Okay. Thank you so much, Kyanti. So, are there any questions? Because I've asked mine already.
Look like there is. I'll what to do. Stop. Yeah.